In this video, we're going to take cosine law and play around with it a bit to show how it's useful in another way. So what we know already is that cosine law is useful in a specific case. And that case is a side angle side situation. So if I'm given side B, angle A, and side C, we say that's a side angle side situation. And so we could write out the cosine law in that case as a squared, because in this case I'm always solving for the opposite side. So a squared is equal to, well, it's the square of the other two sides, b squared plus c squared, minus 2bc cos of a. So what that shows us now is that given this side angle side situation, we can solve for the opposite side. One observation that could be made here is that I have one angle in this formula. So if I'm given an angle, I can then use that. But what about if I'm not given that angle? What information would I have to be given to solve that? And the answer would be, I would need to know a squared, b squared, and c squared. I'd need to know b and c. So I'd need to know, well, all three sides of the triangle. And if I was given all three sides of the triangle, I could substitute the values in accordingly and then rearrange and solve for cos of a. So again, what mathematicians tend to do is that if something happens enough, they tend to like to come out with a general case, and then they can apply that general case with less work on a more regular basis. So what we're going to do is we're going to rearrange this equation so that cos A is isolated for. So a couple ways you can do this. I'm going to do the following. I'm going to start by observing that I have minus 2bc cos A, and I want to make that positive. So I'm going to say a squared plus 2bc cos of A is equal to b squared plus c squared. So what I did was I took this entire component here and I added it to both sides. Now I'm trying to isolate for a here, so I'm going to get rid of this a squared, so I know that 2bc cos of a is equal to b squared plus c squared minus a squared. And now I'm still trying to isolate for cos A, so I'm going to divide both sides by 2bc. So the c's cancel out, the b's cancel out, and the 2's cancel out. So I'm left with cos A equals b squared plus c squared minus a squared over 2bc. Now here's the thing. At this point, some people will say, well, I'm trying to isolate for a, so what I need to do to both sides is I'm going to take the cos inverse. So I'll end up with a is equal to the cos inverse of b squared plus c squared minus a squared all over 2bc. And they'll say, okay, now I've isolated for a. Though this is valid, people often don't do this. What people often do is they leave the cosine law in the form cos of an angle is equal to, in our case, b squared plus c squared minus a squared over 2bc. They'll leave it in this form because we know that a cosine ratio has to be less than 1. So, well, at our point, just to clarify, it has to be less than 1. So therefore, by having this component here isolated for, you can evaluate this and stop to check. If it is less than 1. And that's a kind of a built-in check you have along the way, because we're saying cosine of an angle. So that means the numerator represents the adjacent, or the denominator represents the hypotenuse of some right angle triangle. And therefore, this component here has to be less than 1. And again, that's only in the context that we've learned so far. There's actually cases where it could be 1. So we now have a new version of the cosine law that is used in the case of, and let's take a look at this. Well, in this situation, I have to know A, I have to know B, and I have to know C. So this is used in cases which are called side, side, side situations. When I'm given all 3 sides of a triangle, and I can use those 3 sides to solve for one of the given angles. So the next step is remembering it, and what people often do, or at least one way I do this, is I always start by writing down, well, what angle do I want? I want A. So I remember it's the other 2 lengths, the sum of the squares, minus the length that matches the angle I'm searching for, divided by 2 times the other 2 lengths. And so therefore I can rewrite this as cos B is equal to, well, it's going to be A squared plus C squared minus B squared, matching the angle, over 2AC. Or I could say cos C is equal to A squared plus B squared minus C squared over 2AB. I hope that helped.